Hi everyone. In this video we are going to discuss about the seventh theorem from the geometry of circles. The theorem says the radius is perpendicular to the tangent at the point of contact. So suppose we have a circle as you can see in the diagram, and there is a tangent at the point of contact P. P is a point on the circle and we have drawn a tangent there, which is the white line there, and then OP is the radius at the point of contact, which is P. We have to prove that OP is perpendicular to the tangent. Or you can think of it the other way, that the tangent is perpendicular to OP. In this case, the proof is going to be with the help of contradiction. So first we are going to make an assumption and then we will prove that the assumption is wrong, and then accordingly we can prove that yes, in fact OP is perpendicular to the tangent. So for a moment let's assume that OP is not perpendicular to the tangent. Then let's say we are going to draw another line from the center of the circle up to the tangent, and let's assume that that line will be the perpendicular on this tangent. Here I have drawn the line. For a moment let's assume that OQ is the perpendicular on the tangent. Now if you think about this little triangle OPQ, there if angle OQP is 90 degree, then all other angles will be smaller than angle OQP, because in a triangle we can have only one right angle and the other two angles will be acute angles. So in this case, because we are assuming that angle OQP is a right angle, then all other angles in this triangle will be smaller than the angle Q or the angle OQP. So we can say that angle OQP will be greater than the angle OPQ. And all of that is based on our assumption that angle OPQ is not a right angle, angle OQP is a right angle. With that assumption, we can say then angle OQP will be greater than angle OPQ. So then we can say that the side opposite to the angle OQP will be greater than the side opposite to the angle OPQ. From the theorems of triangle, we know that the side opposite to the larger angle is larger than the side opposite to the smaller angle. So then in this case we can say that the side opposite to the larger angle, which is OQP, will be greater than the side opposite to the smaller angle, which is OPQ. And again, all of that is based on our assumption, and we are going to prove that our assumption is wrong. So from here we can say then the side opposite to the angle OQP, that side is actually OP. So according to our assumption, then we are coming to the point where we have to say OP is greater than OQ. Now let's look at the length of OQ. Well, actually OQ is OR plus RQ. Now what is OR? Well, OR is the radius and that will be equal to OP. So from here, can we say that OQ is equal to OP plus RQ? And clearly OQ is greater than OP, because OQ is OP plus something, some positive quantity. So clearly OQ is greater than OP. Now look at these two relationships. With our assumption, it turned out that OP should be greater than OQ, but in reality we see that OQ is actually greater than OP, which is opposite of what we saw with our assumption. Our assumption led to the conclusion that OP must be greater than OQ, but in reality we are seeing that OP is actually less than OQ, or in other words OQ is greater than OP. So that kind of contradicts what we assumed. That means our assumption is not correct. And what was our assumption? Our assumption was that angle OPQ was not a right angle, and instead we drew another right angle, which is OQP. That was according to our assumption, but that assumption has been proved wrong. So from here what can we say? Since we have been able to prove that our assumption is wrong, we have to accept the fact that OPQ is actually the right angle. And from this diagram you can see that OP will be the shortest distance from the center to any point on the tangent line. P is the point whose distance from the center would be the smallest distance. You take any other point on the tangent line, the distance from the center will be larger than OP. And we also know that the smallest distance from a point to a line is actually the perpendicular distance. So from that aspect also we can clearly understand that OP will be perpendicular to the tangent line. And this is a very important property of circle, that the tangent is perpendicular to the radius, or the radius is perpendicular to the tangent at the point of contact. This is a very important property. Please make a note of it. I hope everything made sense. Thank you for watching. See you in the next video.